All right, let's scale it up. By the end of this video, I'll expect you to understand what we mean by scale as a one attribute shape and have some insights into how to work with various scales in controlled evolution of data model. Scale is how an attribute's data is used. We can generally divide it into these categories. Nominal scale means an attribute that's used purely to name something. It's to identify instances. So Billy Bob Johnson might be the name of a person. User ID as an integer can serve the purpose of identifying a specific user. Ordinal scale is like that, but different. It's used to represent some kind of ordering of a sequence. So a restaurant order number does partially identify one specific customer's order or purchase, but it also represents a position in a sequence. So logically, we know that order 153 is fulfilled before order 154. Numeric scale is used for quantities that make sense to use mathematically. So height and weight data, for example, Maria may be 2 inches taller than her sister Isabella. Medication quantity might be a fraction of someone's weight calculated. And then we have Boolean information, which does not fit in any of those categories. You could say whether an account is inactive, flag that as true or false, or whether an order has shipped, true or false. Notice that this is not the same thing as data type. So this is what the users want to store and not how it is actually stored. To expand on that, we think of integers as numbers, but they can also be used to identify things. Strings are usually serving a nominal purpose, but they can be used in an ordinal way. Floating point values are not recommended for nominal scales because they're imprecise inherently in how they work. But a floating point does work well for numeric and ordinal data. What about dates and times? Well, a date is both numeric and ordinal. You can see that you can implement a time as a Unix timestamp, which is just a number. A date with a time can be considered ordinal, but is usually best to consider it numeric, especially as the time gets increasing precision. So if we start large and we think about the year 2023, that clearly comes before the year 2024, so it's ordinal, but it also can name the year. As we add month and as we add day, we get more precise, but there's still many domains in which some sorts of things happen once a day. They either happen or they don't happen, so there may be a record of something on a day, or there may not be a record on that day, and that's discrete enough that it's possible to use a date as a name. It's possible to use a date as an ordinal position in a sequence, possibly to identify an object. You can imagine, though, that as we get to second and even millisecond accuracy, it stops making as much sense considering those to be ordinal data because people don't work with numbers like that in that way. So to expand on numeric scale, we can think of finer distinctions. We can think of numeric scale values as being continuous or as discrete. So some numbers are inherently continuous or irrational or imprecise. If we take the number pi, for example, it's irrational, and to represent it requires ever more digits to try to get it more and more precise, but never perfect. Whereas a discrete number is representing an exact amount that needs no further representation to make it any more precise. So we call it a precise number or a rational number. When a value is discrete, it means it's understood that there's no values in between. There's a year 2023, a year 2024. There is no logical year 2023.5, even though we could, of course, come up with a time that represents that moment, but it's not what we mean when we talk about years. Discrete numbers make sense to include in an identifier, whereas continuous numbers do not because they're imprecise. If we're trying to locate a specific record and the value we're using to locate it is not precise, then we have a problem. So taking a step back, what scales do make sense to include in an identifier? Well, nominal scales are inherently for the purposes of identification, so of course they make sense to include in an identifier. Ordinal values and Boolean values Yes, but less likely. And Boolean values in particular, a Boolean value doesn't make sense on its own as an identifier because it would mean that you could only have two instances, true and false. But you can imagine the Boolean being part of an identifier, so you can subdivide your data into two halves, a true half and a false half. Each half could have an infinite number of values in combination with, for example, another nominal scale attribute. So it could be part of an identifier in that way. Again, less common. Numeric values depends on how precise and how discrete the values are. So you can imagine having records created once a day, even once an hour, once a minute. But the more precise you get, the less likely it makes sense to use a number as part of an identifier. And especially when you get to continuous values for things that are measured in the real world, such as a weight, it really doesn't make a lot of sense anymore because it's very hard to imagine any kind of database record that should be created or deleted at a particular floating point value and not at the one immediately next to it at whatever precision that the machine is able to handle. So how does scale guide our controlled evolution? Usually, for example, there's no reason to suggest that a date timestamp be part of an identifier because it's such a precise number. If we see discrete numeric data becoming part of an identifier in our conversation, it's a good time to stop and check our understanding. It can be valid to use a number in an identifier, but it's usually not recommended. For other scales, it's still worth checking our understanding. That's always a universal concept. When it comes to nominal scales, they serve the purpose of identification, so there's no doubts in its validity for that use, but it's still worth considering other things like misidentification. Did we choose the wrong attribute to identify? Or under or over identification. Do we still need to add other attributes to our identifier? Now check your understanding. What scale is each of these examples? Once you've determined that, which of these would you say is least likely to be part of an identifier?